So let's look how this algorithm works on the example that we started off with. So we had 6 symbols. So A, write A here, B, C, D, E, and F, right? We have the 6 symbols, and each of the symbols, I'll just write down the frequencies in here. Okay, so 20, 12, let's see here, 10, 8, 4, and 3. Okay, so we have 6 symbols, and we know that each symbol is a leaf in the final tree. Okay, so we create these leaf nodes, the 6 leaf nodes, and now we recursively run that step that we discussed in the previous video, wherein we take 2 of the subtrees which have the lowest frequencies, right, and combine them. So in this case, these two, E and F, these have the lowest 2 frequencies. So we'll simply take them and form a, we'll create, maybe I'll show this. We'll join in E and F here, right? And so they have frequencies 4 and 3. So we label this node, this root node, with the sum of the frequency of these 2 leaves. So that is 4 plus 3, 7. Okay. So 7 is nothing but the frequency. We define the frequency of a subtree. So 7 is the frequency of that subtree. Okay. And the rest remains the same, right? So we have, again, A, B, C, and D, right? This does not change. So this is initially, so this is the first step, right, in the initial stage. Then after the first step, we have these collection of subtrees. Okay, and we repeat the same procedure. We pick the 2 subtrees in this collection which have the least frequencies. So here it is D, which has frequency 8, and this entire subtree which has frequency 7, right? These are the lowest 2. So we will combine them into one node here, which, sorry, again, I have D, and here I will have this entire subtree. So E and F, right? The leaves DEF with frequencies as before. And now the frequency of this entire subtree is the sum of the frequencies of its 2 children, right? So 8 plus 7, which is 15, right? Do you see that? Okay, 15 is nothing but the sum of the frequency of the 3 leaves. And we have the others as before, A, B, and C, right? So this is unchanged. These are the frequencies, and this is the end of, after this second step, we have this. Okay, so we have these 1, 2, 3, 4 subtrees, and now we have to pick the 2 subtrees with the least frequencies, and now we see that it is B and C which have the lowest frequencies here, right? So 10 and 12 are the smallest. So then in the next step, we combine B and C into one node. So here we have B, and here we have C, right? A remains as before. Maybe I should move this slightly down. B has frequency 12, C 10. So the node here, the root node here will have frequency 22, right? A as before has frequency 20. And then we have this subtree, which is unchanged in this step, right? We have D and E and F, right? And their frequency is 15, right? Okay. So this is the end of step 4. So now we have 3 subtrees here. And the same thing, we pick the 2 subtrees which have the least frequencies. So that is going to be 15 and 20, right? So we take A and this subtree and we combine them into a new tree in the next step. So we'll have our maybe write out, I'll keep this subtree as it is. So this is unchanged. And then I have a new subtree, which has on one side it has A, and the other side it has this entire subtree, right? So that would be D, not 7, E, and F, right? So A has frequency 20, this is 15, 8, 7, 4, and 3. Okay, and now 20 plus 15 here is 35, which would be the frequency of this root node. Okay, this is the end of step 5. And now in the final step, we are left with just 2 subtrees. So we just simply combine them into the single tree. So the final tree, uh, it would look like this, where we have so maybe B and C here, A here, then D, E, and F, right? And we can write out the frequencies: 12, 10, 22, 28, 4, 7, 4, 3, 7, 15, 35, and 22 plus 35 is 57. Don't really need to write this out, but this is the tree. Okay, this is the final optimal tree. Okay, now you could pick, as some of you might be wondering, there's no special thing of picking this as the left child and this as the right child. You could have picked the other way. The tree would be different, but the codes you might get are different, but they would have the same cost, right? You could have multiple trees which have the same optimal cost. Okay, and we can write out the codes. So the left branches we're saying are 0, right branches are 1, right? 0, 1, 0, 1, 0, 1, 0, 1. Okay, so that would, now if we want to find the code of any symbol, let's say we want to find the code of symbol A, we just walk down from the root till that symbol, right? So we encounter first a 1, then we encounter a 0. So the code of A is simply, okay, so the encoding of A is simply this 1, 0. Okay. For B, we walk down this path and then this path. So the encoding of B, so maybe let me write them down, A, B, C. Right. So the encoding of B here was 0, 0. For C, it is 0 and then a 1. So 0, 1. For D, we saw 1, 1, 0. So it has 3 bits. 1, 1, 0. E was 1, 1, 1, 0. Okay. And F would simply be 1, 1, 1, 1, 4 bits. Okay. So this would be the optimal encoding. Okay. Or the Huffman encoding, which is a prefix-free encoding. It is guaranteed to be a prefix-free encoding, and which has the least cost.